We have given a rational function given here as x square minus x minus 6, a polynomial on the numerator, and x square minus 3x minus 10 is in the denominator. And our goal is to find the equation of any vertical asymptote if it has on this rational function. Okay, so let's try to do that. Okay, so how do you find the vertical asymptote? A couple of ways. One way is, let's take the denominator polynomial, which on this case is x squared minus 3x minus 10, right? And then try to see where this denominator polynomial is 0. So we try to set this equal to 0. So try to solve this equation. We have this quadratic equation on this particular case, so we can use either the quadratic formula or just try to see if we can reduce up to the linear factor and then try to solve that. So x squared minus 3x minus 10, how can we reduce up to the linear factor? I can write down x and x over here, right? So now I need to think about two numbers whose product is negative 10, but when I combine, I need to get negative 3. Can you think of those numbers? Does negative 5 and positive 2 work? Certainly, right? Negative 5 times positive 2 will be negative 10. So that's how we get the last term. When we combine negative 5 plus 2, we get the negative 3. So it works. So no problem then. So then we reduce these up to the linear factors. Then now we can solve this very easily, right? We can just use the 0 property, which is set negative x minus 5 equal to 0. And then set x plus 2 equal to 0, and then solve those linear equation. If I add 5 on the both side, I get x equal to 5. When I subtract 2 on the both side, I get x equal to negative 2 as the solution. So it turns out that at x equal to 5 and x equal to negative 2, the denominator is 0. So if that is the case, then I can actually write down these equation of the vertical line are the possible vertical asymptotes. So x equal to 5 and x equal to negative 2. I'm not sure yet if both of these two equations are actually the equation of the vertical asymptote. To confirm that, I need to look into the numerator over here, which is given as x squared minus x minus 6. I need to see when I replace x by 5 or x equal to minus 2, if the numerator is 0. That means I need to find the common real zeros from the denominator and numerator. If it has a common real zeros, I need to cancel that out. Those are not the location you can have the vertical asymptote. Okay, so why don't we just check that? So let me plug x equal to 5 in on this numerator. So when I have that, so on the numerator I have x squared minus x minus 6, right? So when I replace x equal to 5, what do I get? 5 squared minus 5 minus 6. 5 squared is 25, 25 minus 5 is 20, 20 minus 6, certainly not equal to 0. Wow, awesome. So this is then your vertical asymptote. Okay, since at x equal to 5, the denominator is 0, numerator is not, so then that is clearly the equation, the x equal to 5 now is clearly the vertical asymptote. But at x equal to minus 2, let's try to check that. So replace x by minus 2 here on the numerator. We get square of negative 2 minus negative 2 minus 6, right? So what do I get here? Square of negative 2 is 4. And then negative negative positive. So we get 4 plus 2 is 6. 6 minus 6 is equal to 0. Wow. So if that is the case, this is not your vertical asymptote then. Because at that now location at x equal to negative 2, the denominator was 0. So this polynomial was 0, but the numerator is not. Sorry, numerator is also 0, right? At x equal to minus 2, the denominator and numerator, both of them are 0 at x equal to minus 2. Then definitely that is not the vertical asymptote, sorry. And at x equal to 5, the denominator was 0, but the numerator is not. And that's what the criteria for you to have the vertical asymptote. So that's why on this particular example, the equation of the vertical asymptote that we need to find out, equation of, let's say, the vertical asymptote is just x equal to 5. Okay, although these are not the standard abbreviation, but I write down these, but you can say that x equal to 5 is the equation of the vertical asymptote. And that's the only vertical asymptote we have. You can check that by graphing this given function.